This is the video for the Algebra 2 Blended class, Unit 2, which is on linear functions, Lesson 1, Day 2. So we're continuing composition of functions today, but this time, this is Day 2, we're going to make it a little bit more challenging than yesterday. Alright, so yesterday we composed two functions, and our input was always a number. Today we're going to compose two functions, and we're going to be having x's in our answers. So let's just jump right into an example. That's the best way to see this composition. So the first example says if we know that f of x is 4x and g of x is 2x minus 1. We're going to do two compositions here. In A it says find f of g of x. And we talked about this yesterday. We said that we want to take the function that is on the right, so start with the letter on the right, and you are going to put it into the function on the left. Now here it's a little bit different than yesterday. Yesterday we had a number inside the parentheses for g. Today we have the letter x. So what you're actually going to do is you're going to take the entire thing that g of x equals, that's 2x minus 1, and you are going to put it into the x in the function of x. Right, so here's how we do this. We look at this function of f here, which is 4x. I'm going to leave the 4 the same, but we are going to change the input, change the value of x for that function. And in the value of x, you are going to put the function of g, 2x minus 1. Now all you have to do to finish this problem is distribute the 4. I'm going to distribute the 4 here, and I will get 8x minus 4. That is your final answer. That is what f of g of x equals. Okay, so let's try another one. The more you do these, the easier they will be. So the next problem says find g of f of x. So this time you are taking the function of f, that's the letter on the right, and putting it into g. So I'm going to take this function of f right here, 4x, and put it into the x variable in g. So when we do that, the 2 for the function of g is going to stay the same. But instead of x here, you are going to put the value of 4x. Then you finish writing the function of g with a minus 1. Now again, all you have to do is combine like terms and distribute. So we have 2 times 4x, which is 8x, minus 1. That is the new function g of f of x. Now let's solidify some things here. Since before we move on, let's make sure to notice something. Yesterday when we composed our function, the input was a number. Right? So yesterday we found things like f of g of 5. And we got an output that was also a number. Okay? So we put a number in, we got a number out. Today we're composing two functions where the input has an x and the output value also has an x. So you're going to always have an x in your answer. Let's try a couple more examples here. For number 2, it says we have the g of x is 3x plus 2 and h of x is 2x minus 4. We are trying to find g of h of x. So that function of h is going to go into the function of g. So that means you're taking h right here, 2x minus 4, in to g. So how we're going to write this is I'm going to take this function of g right here, the 3 stays the same, and the plus 2 stays the same. The only thing that changes is that the 2x minus 4 goes in where the x was. So now all you have to do is distribute the 3 to get 6x minus 12 plus 2. And now you're going to combine like terms. Negative 12 plus 2 is negative 10. So the answer is 6x minus 10. That is your new function. All right, moving on to example 3 here. G of x is negative 3x and h of x is 2x minus 1 over 3. Here we have a funky function notation that says h of g of x. G is going to go into the left function of h. So again, this g right here, if you want to circle it, goes in for the x into h. So let's write down what stays the same in H. We have the 2 that stays the same. We're going to fill in the x. Minus 1 over 3. That all stays the same. So in those parentheses there is where you're going to put your minus 3x. That's what we said is going to go in for x there. Now we're going to distribute and collect like terms. So when I distribute here, I get negative 6x minus 1 all over 3. And that is your final equation. All right, last 2 examples here, and then we'll go on to some practice. These are a little bit more challenging, or at least one of them is. We're going to find f of g of x. So let's start by taking that right function of g and putting it into the function of f. So we're taking this x squared plus 6, that's g, and putting it right over here in for x. So if you need to, let's say that x is our parentheses, that's what's changing, plus 5. The plus 5 does not change from f. Now into those parentheses is where you're going to put the x squared plus 6. Now there's no distributing to do here, you just have to combine like terms. The 6 and the 5 combine with each other to become x squared plus 11. And that is the equation f of g of x. You made a new equation here. The last problem, this is where we get a little challenging. I'm going to be taking f and putting it into the function of g. So this time, you're taking x plus 5, and you're going to put it in for the x in our other problem. So let's set up our parentheses and our stuff that's staying the same to start here. So on my x, that's what's going to change, squared plus 6. Right, that's how g started. Now in for x, you're going to put f, x plus 5. Now the hardest part to remember here is that when I have x plus 5, the quantity squared, you are not allowed to just write x squared plus 25. You cannot just square each term. Because technically what that squared is saying is, think about when you square a number. If I have 7 squared, that's taking 7 times itself. 7 times 7. So if I have x plus 5 squared, I have to write that as x plus 5 times x plus 5. And then I bring down the plus 6. But I have to write my expression that way so that I can get the correct value. Now here you want to do the distributive property, and if it helps you to remember the FOIL acronym for distributing. So I'm going to take x times both terms in the other parentheses, which is x squared plus 5x. And then you take the 5 times both terms in the other parentheses. So plus 5x plus 25, and don't forget to bring down your plus 6 again. So all we have to do now is combine like terms. The 5x's combined to give you x squared plus 10x, and then 25 plus 6 is 31. So that problem has a little bit more involved in it, but as long as you can substitute incorrectly and remember that you're going to have to multiply and distribute, you'll be okay. Okay, so that is the notes on day 2 for composition. I want you to flip the paper over and work on the practice. There will be a short practice video on Canvas that you can check if you need help with any of those problems.